different headache. Okay, so we have a real function which is u, but it is, you have to keep in mind that we have this function r and theta form, not your regular x and y form. So this is gonna be a little pain. Okay, so what is gonna happen is we have to verify it with Laplace equation, which actually proves, like Cauchy-Riemann equation proves your analytic. If your function is analytic, Laplace equation proves that if your function is harmonic function. So, and we also have to find analytic function if it is, and also we have to find f of z and v, which we are gonna do by Milne-Thomson equation. So I would give you basic formulas which we would need today. So what we would do in Milne-Thomson formula. Milne-Thomson formula. Okay. This is formula is integration phi 1 z no, z comma 0 dz plus minus I integration phi 2 z comma 0 dz. Okay, where phi 1 is equal to del u by, if so these would be different when which function is given. Here real function u is given. If it was v function it would be different. I would tell you that later. Now we would study about like u. If u, the real function, is given, so when real function is given you just have to do it. U, with u, which function goes first? Like u is a u and v are function of f of x comma y. F of x comma y, right? So which is first, x, and which is the first letter in this? F of z equal to u plus iv. So u is first letter here, right? In f of z. So in f of x comma y, which is first letter? X. So here both are first. So x and u are related. Okay. Yo, one people came to the stream. Yo, welcome to the stream, man. Thanks for coming. I'm really grateful to see you, man. What's up? Welcome to the stream, man. For real. So yeah. So in u, whoa, 7 people came. What's up, man? What you doing? What y'all doing, bro? How's your day going? For real, bro? Just tell me in the chat section, man. Whoa, 18 people, I'm really grateful. Thanks for coming on, man. I really appreciate it. For real, man. So yeah. If in u and v function we have actually it is function of x and y. So which is the first function of in u and v? So it is x is first. So in f of z, which is the first function, is u plus iv. So u is the first function. Okay. So if u is the first function in z and x is the first function in u, so x and u are related. So the phi one should be the first one should be which is related. So del u by del x should be the first stuff. Okay. Now second stuff would be equal to the other one. So we have to just this is del x. So we just only have u. We don't have v. We have to find v. So we can't do anything with v. We have to do everything with u. Now first I do del u by del x. So what else is remaining? What can I do? Like different thing, because we need two functions here. Like we need a real part and a imaginary part in our formula. Okay. So f of z is equal to this stuff. Okay. So we need two two functions. Now for that two functions, first function we found. Now for second function, what can we do with this del u? Now we did del u by del x. So del x stuff we did. Now what is left? There is y in that. So we can do del u by del y. Okay. Del u by del y is here. Okay. So now what happens is, so we did this. Okay, we did this. So now what happens is we would just put it in here and things would be fun. So now after that, so you have to understand that u is equal to x plus iy in Cartesian form. But u is equal to r e raised to I theta. So this is complex number how we represent real part, imaginary part. Or this is the magnitude part, this is the direction part. So in the polar form, wait a second, let me reduce the background noise. And wait a second, I have to reduce the background noise again. And here it is, not reduced. Yeah. So now what happens is, uh, so in x plus ry, this is the direction. This is the magnitude. This is the direction. This wait a second. This is a real part. This is the imaginary part because this is I is imaginary number root minus one. So it is some multiple of this imaginary number. So it is imaginary number, and this is like this is imaginary unit kind of thing like I. Okay, yo, 25 people, what's up, man? What's up? Welcome to the stream. Really happy to see you all, man. Glad to see you all. Just come on the chat section, bro. The chat section is open. Let's interact, man. This will be really cool, man, for real. Come on in the chat section, man. Why not? So yeah, you then this is like normal Cartesian form. This is angular form, like polar form. So what we do here is, this we just take this magnitude as mod. Okay, so this would be x square plus y square, right? So what did I do here is, this is like, this is a real form, this is imaginary form, this is a real form, this is imaginary form, because there is I here, and this is actually no, this is magnitude, this is direction. So this is magnitude, this is direction. To find magnitude, we just take the mod of it. Like R is, we can convert these, okay? Like let me tell you, like yeah. So A is equal to R cos theta. Like X is equal to R cos theta, and Y is equal to R sine theta. So it is totally interconvertible, okay? So this is totally inconvertible. Like there is R, so R is this. E is a constant, I is a constant. Theta also we can find. Theta equal to tan inverse y by x. So this is direction, okay? This is angle, this is direction, whatever you call it. This is magnitude. This is magnitude, this is direction. And we can these are interconvertible. Okay, so you get that, right? So what do we do here? So how are we gonna use this? So first thing is we have to find a Laplace form. So there is a Laplace equation. Cartesian form is different. I will tell now later on. But now I'll tell Laplace for equation for polar form. Okay? In polar form, you do is d square phi by del square plus 1 by I d square del phi by del r plus 1 by I square del square phi by del theta square. So equal to 0. Okay. So in harmonic or Laplace equation, either it is Cartesian form or it is uh, polar form. In both of the form, it should be equal to 0. Okay, it should be equal to 0. Now what happens here is you take del square phi by del r square. Okay, like you have R equation, so you like in Laplace or harmonic equation condition, we do squares of the stuff. Like in physics, you must have studied this divergence function, which is delta square. So we just multiply it to our function. So what this means is del square by del x square plus d square by del y square. Okay, del y square. So this is this function. So we just multiply it here in polar form. So what happens is, so we just equated to 0 in both harmonic functions. This is about the Cartesian form. I will show you later, okay? So this would create confusion here, so I would erase this, but you just saw it, right? So yeah, now I will erase it. So it would be in square form. So first would be del square phi by del r square. Then we would remove that r. Like I'm just telling this that you can remember this, but this is not how it is derived. It is kind of tougher. Okay, you have to use all this and you have to just derive it. But deriving is not our concern here now. It is kind of difficult, and it is a separate topic. Okay, we just have to focus on its applications. Okay, now del square phi by del r square. So first is so we have only one function, which is phi. Okay, in our even Cartesian form, we just grab a function, we just put divergence or curl equation, curl of a vector equation, we just put on it, and we just continue our operation, and we do it separately with u and with v. So here also we only have one function, which is u, so we just do that only. So what happens is here, first so one function is only there, so we have two function, so that function is made up of two variables, which is r and theta, which you see here. So it is a function of, u is a function of r and theta, right? So which is first? R, which is first here? U, like u is function, first function in f of z, and r is first function in u, like, so when so u and r are related. So first, let's say we would take r, okay? We would take r. So del r squared. So first, so this is a square function. Like Laplace equation is square function. I told you. Like every harmonic function, we just do a derivative, double derivative, like del square function. Those are okay. So del square phi. First we derivative with double derivative with del r square. Hi, on Asox is X in Excellency Beauty. What's up? Welcome to the stream. So yeah, in Laplace equation, wait a second. So in Laplace equation, so del square phi but del r square is there, okay? So del square phi, first we double derivative with respect to r, okay? Del square phi but del r square. So this is the first, first function. So we give priority to first function. So now there would be two terms of this. Now other term would be this, okay? So we would focus on that later. So now here, this is, let's say, 1 by r raised to 0. So anything raised to 0 is 1, okay? So it is 1. So nothing is here. So what happens is 1 by r power increased. So now it is 1 by r raised to 1. So it is 1 by r, okay? Del square phi by del r square, first thing clear? Like square form. Now we reduce the derivative power. Like we do single derivative now. We reduce the derivative power. So now it is del phi by del r. So del r stuff is going on now. 1 by r is here. Because 1 by r power is increasing and derivative power is decreasing. Okay. So see. Wow, another person came. Hello, second two persons are there. The people are there. So yeah, you were there. So I had done some explanation. I would just recap it a little, okay? If you have missed that, okay, he's left. So, anyways, I should do that explanation. So phi square, so del square phi by del r square, okay, plus so now I would reduce the so this was the first function. We have to do derivative of this function with both the functions that is inside, like r and theta. So first we choose r. So we since this is a square function, so we double derivative this del square phi by del r square we do. With respect to r we do double derivative, then we do plus, then here it was 1 by r 0, so it is 1, so there was nothing, okay? Now we raise that power, we raise the power of 1 by r, which is multiplied, and we reduce the power of derivative once like we go ahead, okay? So now it was double derivative del square phi by del r square. So now we reduce its power. Now it is single derivative. So derivative raised to 1. There is no derivative raised to 2. Now derivative del square is not there. That square we have reduced. It is now just del raised to power 1. Okay. So we reduce the power of derivative. So it is now single derivative. Okay. Del phi by del r. Okay. And this we have increased the power. Here there was nothing. Now there is 1 by r. Like I have increased the power 1 by r raised to 1. This was 1 by r raised to 0. So it is 1. So there is nothing. Now after this, now after this there would be nothing because its power is reduced. Like there would be no derivative. Okay. So now this r function stuff is done. Now plus now 1 by r square, because we are increasing the power of this. Now this was 1 by r, so we have to increase the power of r. So now it is r square, r raised to 2. Okay, I increase the power of r. So but I have to do now theta. So this is a, now it is del square phi by del theta square. Why? Because we are focusing on derivative, doing derivative with respect to the other function theta. But what is the problem here? Del square, since it is a square function. Yo, four people, what's up? Welcome to the stream, man. Why not come on the chat and yap a little? Why not? Come on, bruh. So yeah, del square phi by del theta square. We can interact a little, yap a little. Come on the chat, man. If you want to ask anything, if you want to say anything, we can just yap, you know. Just come on the chats. Yo, bro, 12 people. What's up? Welcome to the stream. Thanks for coming, bruh. Like, really grateful for that. I'm really glad to see you all. Why not come up in the chat? It'll be really fun interacting, you know. Come on in the chats, bro. It'll be fun interacting with you all. For real, bro. Come on the chats, bro. You will look cool, chill guys, man. So why not? Yeah, bro. Just come on, we can interact, man. For real, man. So yeah. So what do we do here is I increase the power of r. So 1 by r is now 1 by r square. I increase the power of r. Now what would happen is I have to, so this power of like this derivative of r slowly and steadily after reducing power it, and like it is 0 now, because this was one power, like single derivative. After this there is no derivative only. Now since the other first function work I have done, other function is left, which is theta. So I have to do I have to take derivative of this function with respect to theta. Now del square phi by del theta square. Why did I took square? Because I told you Laplace or harmonic function condition, we have to do double derivative, or it is del square function. So I do first I have to do del square only. So del square phi by del theta square I do. But now I don't reduce the power, like there is no single power derivative term, because this is second function, we don't give it priority. Simple. So yeah, that's how you can remember this formula. Now the third thing we would need is like analytic, to check analytic condition. By the way, this is harmonic. Okay, you check if the function is harmonic with Laplace. Now with analytic, what you would check is for analytic function, how you would check is, yo, four people, what's up? Welcome to the stream, man. Four people, bro. What you doing, man? Just come on in the chats, bro. We can interact, bro. For real. Come on, bro. Like, why not? Yeah, bro. Come on. Okay. So we are gonna check analytic condition. For that, what you would do is, I would take Cauchy-Riemann equation in polar form. Okay. Yo, far people, what's up? So Cauchy-Riemann equation in polar form would be, like we used to do in I told you previously, like in Cartesian form, our CR equation was del u by del x is equal to del v by del y, del u by del x or del y is equal to minus del b by del h. So what is happening here is, we have to, like both functions are there. So so this is related function, like I told you. So first function in u is x, and the first function in f of z is u. So first, both are first function in their respective calculations, so they are related. So I do del u by del x equal to del v by del y. These are also related because they are second functions in their respective equations. Like in f of z, v is second, and in u and v also x plus iy. So y is second in imaginary form. So what happens here is del u by del x equal to del v by del y. So these are related stuff. So when they are done derivative with respect to each other, they stay positive and equal to. But when we have done with this, now what we can do, what is possible, we can exchange the with respect to derivative, like denominators. Okay, now we exchange the denominators. Del y comes here, del x goes there. So now they are unrelated because this is second function in u, and in f of z u is the first function, they are not related. So what do you do is you take derivative equal to, now this is opposite of what it should be. This is first function in its u and v is the second function in f of z, like in imaginary part. So now this is also opposite. We took the derivative of each other in that respect, like opposite respects. Now what would happen is, since this is opposite thing, so we put minus sign. So the equation is now a whole opposite. Minus is the opposite sign, right? Now opposite derivative and opposite sign balances each other, and it is still equal, nothing changed. So now we get two equations like that. What I would do here is, we would do same thing, del u by wait a second, del u by del r equal to del v by del theta to 1 by r. Since here 1 by r comes every time, so here also. And Cauchy-Riemann equation is a linear equation, so there is no square term in this, there is no double derivative in this, there is no del square term in it, so there is only simple one derivative in this. So yeah, del square u by, and so there is two equation exchanging the functions. So here it was del r and here was del theta. Now exchange this. So now this is del theta and this is del r, del v by del r. Now when we do opposite of it, what do? We put a minus sign, and since we love to put r here, so here it was 1 by r, opposite of that is r, right? Like positive opposite is negative, so r is multiplied, so opposite is divided by r, or what we call is 1 by r multiplied to 1 by r. So what we are doing is, so when it was like this, like, so what I'm saying is, u, in u, r is the first function, right? Second function is theta. So and u is the first function in z, v is the second function in z. So u is the first function in z, r is the first function in u. So these two are related. First I did this del, and this also I did derivative, which is, these both are related because these two are second function in their respective function. Like theta is second function in v, and v is second function in z. Okay, right, you got it right, r e raised to I theta. So this is imaginary second thing and this is first thing, real part. Okay, so this is how it is. So what happens here is, so this is related, like first function in the respective function, second function in the respective function, v and theta, u and r. So they are related and they are becoming derivative with respect to each other. So this is good case. So what we do is positive, there is no negative sign here, this is positive, okay, and 1 by r. Now what we do is we exchange the, with respect to denominators, like del denominators, like derivative with respect to thing we exchange. Now when we did this, it became opposite. To balance that, we would put opposite sign minus. Here it was plus, I did minus, and here it was, since there was 1 by r, we also did opposite of 1 by r, which is r. Now I put r here because multiplying into r, multiplying r and 1 by r is totally opposite, so I did opposite stuff. Now negative sign and r also opposite, so this balances the opposite thing we did in exchanging the, with respect to denominator del derivatives. Okay, so these were the three things we have to do. Now what would be the order? First, we have to do Laplace. This is the easiest part. We have to do this, only need this, and we have to take this out, and we have to have fun. Now, after that, we can't do this because in this we need v. We don't have v, we only have u. This doesn't need u or v. Any function, you can just put it, find harmonic function, have fun. But the problem is this one. What would happen here is, we need v. So for v, we don't have v, we have u. But can we find v? Also in this question they demand v. So we would find v by this. So we have to second step we have to do Milne-Thomson. Then we will find v. Then we can do analytic CR function. Okay, like we can check it if it is analytic. So let's get into it. Wait a second. I would, I would. Okay, orientation is locked. So I have to, give like zoom out in portrait mode. You can take screenshot or notes. So you can take screenshot or notes, and let me zoom out. Take screenshot or notes. I would erase it. I would erase it. Here we go. A success in excellency beauty says you're teaching in a very good way. No way. I'm dumb, so I don't even know all this myself. How can I teach this? We are just discussing. I'm a dumb guy. I'm not a teacher. And I also don't know anything about this. How can I even teach this? And anyway, I'm bad at explaining and teaching. So, yeah. So, I am not teaching in a good way. You are a good person. That's why you are saying good things. You might be a good teacher. That's why you are saying good stuff about others. Like good teaching stuff you are saying because you must be a good teacher. Because good people reflect good things, right? So, yeah. So, you are a good teacher. I am a dumb guy. So, I am not a. No, forget about teacher. Forget about good teacher. I'm not even a teacher. I'm not even like good at this. I am dumb at this really. Yo, 7 people, 5 people, what's up? Welcome to the stream, man. So did you take the notes? I gave you like formula. You have to note this down, bro. So yeah, now I would erase it. We would do this step by step. Okay. So first we would go for Laplace equation. So I would erase everything else. So why would I would erase it? Let's just do it, bro. Like for Laplace equation, it's in the middle, so I don't even need to erase all this. Let's just do this, okay? So del square phi by del r square. So what del square phi by del r square means? It means del by del r. So what double derivative means, I would show you, okay? First, you have to write del by del r, put a bracket, then your derivative del phi by del r. So now what this stuff means? Now you have to take derivative with respect to r of del phi by del r, or like you have to take derivative of phi with respect to r. Then after doing this, whatever answer comes, you have to again take derivative with respect to r. So you took derivative of phi with respect to r once, that result came, that answer came, you have to take that answer or results derivative with respect to r again. Now that is double derivative, okay? So let me show you how to do it. So it would be first I have to find that function. So cos theta would be multiplied to both the functions inside because it is outside the bracket. So what I would get is r cos theta plus a square by r cos theta. Here we go. Now what would happen is uh, now del square I have to do it, right? Del square del r square. Yeah. So what this means is, this means like denominator there is del r, which means I have to derivative with respect to r. What does it mean is I can do r derivative. I can only differentiate r as a variable. As variable. And what would happen to other things? Others are either constants or coefficients if multiplied to r term, like whatever with respect to term is there, this time it is r. So whatever, if it is multiplied to r term, then it would be coefficient, and if it is not, then it would be a standalone, it would be constant, and r variables would be considered as variable and would be differentiated. Now I have to show you. Now d by dx, k is a constant, so k of f of x would be, k would be just taken out, and multiply later directly after we take derivative of the variable or f of x. Now another thing, d of x raised to n is equal to nx raised to n minus 1. Simple. Gotcha. Yeah. So, I might need cos theta also. So d by dx of cos x is equal to minus sin x. D by dx of sin x is equal to cos x. So what do you get is, so derivative of cos x is minus sin x, derivative of sin x is minus cos x. So they are just becoming opposite causes, because sin is cos. Only from cos to sin you have to remember there is minus sign. Okay. Yo, someone just said something. Oh, I'm really sorry. I deeply apologize. Like I really missed it, bro. I wanted to like read it, but I by mistakenly missed it. I'm really sorry, bro. Thanks for your chats. I really appreciate it. Thanks for the chats, bro. So Sarkar Fateh Salah says M. Okay, M. Sarkar Fateh Salah says JM. JM means jelly or jelly me or what it is. JM, I don't know what it is. Like kilometer is km, so jm is joule meter or something. Like, no, there is nothing like that, because they are different dimensions, like different units of different stuff. Like joule is of energy and meter is of distance, so it is not. Sarkar Fateh Salah says H. I guess H means supposed to be hi, I guess. So, hi, bro, what's up? And Sarkar Fateh Salah says hello. So, hello, what's up? Welcome to the stream. Thanks for joining. Really appreciate it. Really grateful. Really glad to see you in the chat section. And Sarkar Fateh Salah says 6767. This is not school, bro. You don't have to do 6 7. I know I'm boring, but you this is like optional entertainment platform type stuff. So I don't think so. This is cool and boring, and someone is just like saying if you are not giving your attendance, then your grades would be reduced. So there is no stuff like that. So you don't need to even do 6 7. 6 7 is meant to do for chaos. Joke for chaos. And it is done to previous generation, and I think I am of your generation only, so that 6 7 doesn't work. And Sarkar Fateh says bro. So what's up, bro? What you doing, bro? So I don't know what exactly wanted to say, so I don't know what I should have replied. So yeah, this is the reply. So yeah, if you have something else to say, you can just say. It'll be really cool to interact. It was fun. And thanks for talking. So yeah, what I would do is, so we have to only take derivative of r here. Okay, we have to take derivative of r terms. Others would be, others would be constants or coefficients. So r, this is r square, r term is there. Cos theta, this is theta term, not r term. This is a different function. So what we have to do is, we don't take its derivative. We would just treat it as a constant. But since it is not standalone, by the way, I have to tell you, derivative of a constant is equal to 0, and when derivative is taken of two functions together, f of x plus g of x added, they can be taken separately. D of dx f of x plus d by dx g of x. So we can take it separately. That's how it works. Simple stuff. Now, what I would do is, we have r, which is actually r term. Like with respect to r, we are doing this. So r term would be considered as variable and we would differentiate it. Cos theta would be taken as a constant, but it is multiplied to r term, so it is joined to r term in one term, so it would be taken as coefficient, not constant, so its derivative won't be 0. Plus a square cos theta, this a square cos theta is different from r, so they are constants or coefficients. They are coefficient because they are multiplied with r term, and divided by r, the r thing is r term, so we would take its derivative. Let's do the first derivative. Okay, del by del r. Now I am doing derivative, so r cos theta, let me show you. Cos theta taken out, because see, what I told you is the derivative of constant into function is equal to constant taken out, then derivative of function, then multiply with it with that constant. Simple. So this is constant taken as coefficient. I would take this cos theta out, then I would do del r by del r. Now it's supposed to be 1, right? Del r by del r is 1. Come on, bro, you have to understand this, because r is raised to 1. R is raised to nothing means r is raised to 1. Now when d by dx of x raised to n is equal to nx raised to 1, we have to use this formula. So dx raised to n, so what is in raised to, that would be n, right, by comparing this. So here what is in raised to 1, so this 1 we have to operate. Now that 1 that n came from raised to 2 coefficient, and that raised to power reduced by 1, so that was n. Now here we have to do same with 1. We have to make this 1 as coefficient, n x raised to n minus 1. We have to also reduce this by 1. This became 0. Anything raised to 0 is 1. So this is raised to 0, so this became 1. So 1 into 1 is equal to 1, and so this became 1, and 1 into cos theta would be that only. Anything multiplied by 1 is that only, so cos theta into 1 is cos theta, plus what I have to do now. Okay, so a square cos theta are other term, these would be taken as coefficient outside. Now what I would do is, this would be r raised to minus 1 uh, derivative, because I told you 1 by r is equal to r raised to minus 1. Since multiplied by r is r raised to 1, okay, wait a second, I had written it here. Multiplied by r is r raised to, multiplied by r raised to 1. So when we, like, wait a second, let me tell you, power is multiplying itself repeatedly. When it is negative power, negative, which means opposite of multiplication, which is division, so division repeatedly. Okay, so since this is r raised to minus 1, so this is like opposite of multiplying to r, so this is dividing r. Opposite of multiplication is division, so it is dividing into r. How many times? 1 times, because it is minus 1, not minus 2 or minus 300. Then it would be that times divide, okay, to that r itself. Okay, so now what we'll do is, this is r, because this is 1 by r, a square cos theta. This r we can take it out and we can write it as 1 by r. Okay, so here this would be r raised to minus 1. Now r raised to minus 1 derivative I have to show you. For that, r raised to minus 1, what is in raised to minus 1? And like derivative of x raised to n, in that what we say, x raised to n. So raised to thing is n, right? Raised to thing is n in x raised to n. So here r raised to minus 1, so raised to thing is minus 1. So minus 1 is n when we compare this. And we operate n. So it is nx raised to n minus 1. So we have to do this here too with this minus 1. So this n from power we made it coefficient and we reduced this power to by minus 1. Okay, by 1. So I take this minus 1 and put it in coefficient and reduce this 1 by minus 1. Now what this minus 1 means, since these are same sign, so they would be added and the sign would be kept intact. So minus took out because both had minus common, so I did 1 plus 1. Because like let's say minus 1, so if I multiply it with minus 1 it would become plus 1, or divide it with minus 1 it would become plus 1. Like these would cut, right? So I just did that only. These both were minus 1, I multiplied the minus 1 to this whole thing, then it become minus bracket out 1 plus 1. If I multiply this minus 1 again inside to both of them, it would become same, minus 1, so nothing changed. And anyway, I can explain it like, if you take debt like 1 rupee 1 orange, I took 1 orange from you, let's say you took 1 orange from me. Now I have minus 1 orange. I didn't had orange, I had to pay you orange. Like let's say like I took debt from you. Like I bought something from your shop and I didn't pay. Okay, I said I would pay it later. Then I have debt. Now I have 1 rupees debt. I took a chocolate. Now another time I took a chocolate, I have more 1 rupee debt. I have to now any time later, I if I earn, then I have to pay you 2 rupee, because that time I had 1 rupee debt. Another time I made 1 rupee debt, so debt increased. So now I would have to reduce my from my earnings minus 2, because I have minus 2 rupees debt now. So when I like 1 rupee debt, then 1 rupee debt, it increased, debt increased, it became two, debt added up. Then when I earn, then that minus would affect my earnings. That would reduce my earnings in future already. So that is minus stuff. Like that is debt. That is the stress of mine. That my minus two would reduce someday. So that debt increased and it would be minus on my balance, like whatever my money total storage is. Okay, so that's how minus works. So this would be minus 1 plus 1 is 2, so this would be minus 2 raised to minus 2. Now what this means is minus 1, what I said is r raised to minus 2 means uh, like minus means 1 by r, right? R raised to minus something is dividing by r, because in like r raised to something means multiplying it with itself that number of times. So when I do a negative of it, opposite of it, negative means negative sign means opposite of that. So when I do opposite of it, multiplication opposite is division, so I divide that r, so with itself some amount of times. How many amount of times? That would be same, like 2, the number which is there. So that was same. So r square, 1 by r square. So we would do this here. I took derivative. Now this is a square cos theta by r square. Now I would erase this. Now again I have to do del by del r. Okay. Now if I do del r again, now this is cos theta. This is theta function. There is nothing r function multiplied here. Plus separates two terms. Multiplication or division joins the terms. So there is no multiplication or division with r term. So there is no r term joined with this in this term. So this is standalone constant, because this is constant because this is theta, other variable than r. When this is other variable than r, it is considered constant and it is not multiplied with any r term. So r was variable here because it is with respect to r differentiation. So r would have been there, then it would be coefficient, but now r is also not there. So this is constant. Derivative is constant is 0. So this is 0. It would be 0. Okay. Yeah. So this would be 0 plus a square cos theta. Okay. Now this is 1 by r square, which is r raised to minus 2. r raised to minus 2. Yo, two people came to stream. What's up? Yo, hello, welcome to the stream. Why not come to the chat section? Okay, he left. Okay, so this is a square. So this is a square cos theta. These are constant because these are other variable terms than r, and here we are giving respect to r. With respect to r, like differentiation is going on, so it is not related to r. So these are constants, but these aren't standalone. These are divided by r square. So divide and multiplication joins terms. So this is joined with r square. R square is a r term. So this is a variable, treated as a variable because this is r with respect to r derivative. This is r term. This would be differentiated, and this is with this. Now this is coefficient, not constant. This is the variable we have to work with. So now what do we do with coefficients? Yeah, here I said it. We just take the coefficients out, then take derivative of the function, variable or function, then just blindly multiply that coefficient later. So what we do here is I take this a square cos theta out and divided by r square like this I shown you. So this is r into r two times itself multiplied, but multiplied it is divided. So it is done opposite. So negative sign, when we multiply it, we balance it by negative sign, giving it opposite sign. So here we are doing opposite of multiplying, like power thing. So when we do opposite of power thing, we put opposite sign, which is minus sign. So here we were dividing, so I put minus sign here, and this was r raised to 2. So 2 times r was getting divided. So this also means same. So I multiplied it with 1 by r square. So it is also dividing by r square, but it is in much simpler form, which we can do derivative. Now what would happen is r raised to minus 2, right? Take derivative. Nx d raised to d of x raised to n is nx raised to n minus 1. Now x raised to n. Here then here raised to thing is minus 2. So here is n. So n is here minus 2. So we have to operate n here like nx raised to n minus 1 we do. So here we have to do minus 2 we have to operate. Now what do? We take this power n in coefficient and reduce this power with minus 1. We reduce it by 1. So now what we have to do here is we have to take this power here, multiply it, and we have to reduce this power with minus 1. Since these are both minus, so minus things are getting increased, like debt is getting increased. So I also took minus common out. I put it in bracket. So this would be plus, because when minus is out, this is opposite sign. Plus, this was minus, so it became plus. This was minus, this became plus, because opposite sign gives minus. So I took minus. So I would take the opposite things, so it would be plus plus. Also I can explain that like that when I like minus is multiplied inside in the bracket, so it would be minus minus again. So it is the same thing also. So what would happen is 2 plus 1 is 3 minus 3. This is, oh boy, marker died or what? Yeah, minus 3. So minus 2 raised to, yo, one more person came up. Welcome to the stream. What's up? And he went. Thanks, I guess. So yeah. So this would be since this is minus, so it would come here. Minus 2. Was there 2 here? R cube. So this would be R cube. Yeah. Now this is the double derivative of this stuff. Okay. Del square phi by del r square. Okay. Now I guess I have to do it in parts, bro. So 1 by r would be, oh sorry, what am I doing? Not 1 by r, 1 5 del phi by del r. So we also did that, then only we got here, right? So one time we did a del phi by del r, we got cos theta plus, wait a second, why I'm doing this? Why am I writing 0 here? So this is single derivative we did here, we got this. So we also have del phi by del r. Del phi by del r. We now only need del phi, del square phi by del theta square. Now what do we need is, this would be del by del theta. I told you, like this is gonna be 2 times. So first time right here, then bracket. Second time we would do it with function del theta, because we have to do this, then whole result that we have to take derivative, which is double derivative. Okay, now what do I do here is uh del phi by del theta. So what do I have here is okay, wait a second, did I do some mistake? No, I don't know. R cos theta plus, so first I have to find del phi by del r. Okay, del phi by del theta, uh the r cos theta plus a square cos theta by r. Okay, now what I do here is, so I have to, so what this means is theta would be differentiated, others are constant or coefficient if multiplied by theta, multiplied or divided by theta in sorry, in same term. Yeah, so yeah, now this is that. Now this that what am I saying, my grammar is going downside, my grammar is dying. So yeah, so same term, right? So here cos theta we have to take derivative, because theta with respect to theta we are doing, and this is theta term, so this is taken as variable, this is taken as function. We would derive it, because this is theta term, this is theta, with respect to theta we are doing derivative. But here it is r, we don't care about r, because r is other variable than theta, and here we are taking derivative with respect to theta, so r will be taken as constant. But since it is here joined in same term, like multiplied with cos theta, like theta function, so it is coefficient. But coefficient, what do? We just throw out coefficient, take coefficient out, and we take variable of take variables derivative, then we blindly multiply that coefficient as it is itself to that derivative result of that function. Just multiply. Okay, we are gonna do that. R cos theta, so what is the derivative? D by dx of cos x is minus sin x, so minus sin theta plus, what is it here, so a square by r is coefficient, because it is other, a square and r both terms are different than theta, they are constant, but since they are multiplied with cos theta, which is a function of theta, like which with which we are respect we are taking derivative, so this we have to consider as function, and we have to take its derivative. Theta term, same term it is, like function it is the same variables, so we have to take its derivative, treat it as a function. So that's why, and so a square by r is joined by multiplication and division with cos theta in one term. So they won't be treated as standalone constant making derivative 0. No, it would be treated as coefficient, and we would just do it like it says here, throw the coefficient out. Wait a second, let me show you. Throw the coefficient out, and then take derivative of the function, then multiply blindly this coefficient with that derivative result. Okay, I do that same thing here. So a square by r taken out, cos theta derivative given here, derivative of cos theta is minus sin theta, so I do minus minus sign here, minus plus, minus into this plus is minus, minus sin theta here, and we are done. Now what I would do is double derivative. We have to take double derivative. Del square phi by del r square is equal to del of minus r sin theta minus a square by r sin theta, wait a second, sin theta by del theta. Now we have to do this again, do the whole process again. So I would just do it faster and I would explain it later. Okay. R is outside. Sine theta derivative is given here. So sine derivative of sine x is cos x. So cos theta minus, so sine theta derivative is derivative of sine x is cos x. So it is cos theta cos theta. So what I did here is r is a different term than theta. Treated as constant because this is theta respect derivative. So we are respecting theta only. Theta terms would be treated as functions and took derivative. We take derivative, taken as derivative. Okay. So r is different than theta. This is constant. Sine theta is a function of theta. Same theta variable stuff it is. So this would be derivative. So since this constant r is multiplied with this sometimes of this variable function, so joint in this term with sine theta, so it would be not taken as standard alone constant, it would be taken as coefficient. Coefficient rule I said here, just take the coefficient out, take derivative of the function, multiply the coefficient, simple. So I do that here, taken coefficient out r minus r, sine theta derivative took like I showed you cos theta minus, now a square by r, a square and r both are different than theta, no theta term, these are not theta terms, so they are constants, but they are not standalone, so they are not constants, they are coefficient because they are multiplied with sine theta, and sine theta is a term like function of theta. See, same theta variable is there, and this is function of theta, sine theta, something of theta. So this sine theta would be taken as function and would be taken, it would be differentiated. So this is a square by r into sine theta. So sine theta is the function taken derivative of, because it is same as with respect to theta term. This is theta term. So we take its derivative, but since it is multiplied with this, joined with this, multiplied and divided, like a square by r, so they are joined with this term. So they are coefficient, and coefficient I told you, coefficient take out, take derivative of function and just multiply the coefficient blindly later. So took a square by r out, took derivative of sine theta which is cos theta, and multiplied this a square by r to cos theta, and we got this. Okay, now let's just according to yo, 2% came up, sorry for the cough. So there are let's compare it to this function we have here, which is something something. Okay, wait a second. So this equation we have to compare this. Do we have del square phi by del r square? We have it, which is 2a cos square theta by r cube. Okay, this is r raised to minus 3, and r raised to anything, which means multiplying itself some amount of times. But since this is opposite sign, negative sign, so we do opposite here. My opposite of multiplication is division, so this is divided by r 3 times. Okay, so what it is, so let's take this. So this would be 2a square cos theta by r cube. Okay, and 2a square cos theta by r cube plus 1 by r is here, 1 by r. Now del phi by del r. Wow, 2 people came. Yo, what's up? Welcome to the stream. Another person came. Really grateful to see you. Thanks for coming. Really glad to see you. You can we can interact in the chat section. Why not come up in the chat section? So yeah, so this is 1 by so this is 1 by r. So this is del phi by del r. So del phi by del r did we find? Yeah. So to do double derivative, we had to do first a single derivative, then we had to take derivative another time to do double derivative. So we did first single derivative. So obviously we have del phi by del r. Del phi by del r is single derivative. No square is there, single derivative. We did this. Then after that we did double derivative on top of the result of single derivative. So we have single derivative definitely, bro. So we have to multiply 1 by r. So this would be then okay. Let me first write it. So it won't be fitting here. So 1 by r. By the way, this is a separate stuff. Okay. Sorry, no space is there, so I have to write it here. So 1 by r, this is 1 by r. Now what is here? 1 by r cos theta plus a square cos theta. Cos theta plus e square cos theta. Cos theta r square. So what happens is it would be multiplied to both of these because this is out of the bracket. Simple. So what would happen is cos theta by r. I would erase this, and since r it is 1 by r, so 1 by r means below this is so what did I say? A fraction is numerator by denominator. So what, when we multiply numerator by denominator, another function, numerator by numerator is multiplied, denominator to denominator is multiplied. Simple. So if I multiply this by 1 by r, 1 into anything is itself, so it will be a cos square, a square cos theta. Here 1 by r, so r is the denominator, I multiply this with r, what would happen? Like, so this is r into r, like raised to number thing is like how many times I multiply it. So this is multiplied 2 times it to itself. So r square means 2 times multiplied to itself. Now another time I multiply it to that r only, like now it is 3 times multiplied to itself, so it will be cube, r cube instead of r square. Simple stuff. R cube, wait a second, r cube, done, right? Wait a second, I guess I erased something. No, this was just braces. Now let's say yeah, this is like this. So now what happened is this is second term we found out. Now plus 1 by r square plus this is separate stuff, 1 by r square into del square phi by del theta square, which is minus r cos theta minus a square by r cos theta. We found out, right? Here it is. Now I have to multiply this whole stuff by minus r cos theta minus a square by r cos theta stuff. Okay. Now what is happening here is so this is out of the bracket, so it will be both. 1 by r square, what I told you, I would multiply 1 by r square here. So what would happen is numerator into denominator, denominator by denominator, we multiply two functions like this, like top we just multiply corresponding numerators and denominators. So that's how it is. So r cos theta by multiplied by 1, same thing. Now here there is r square in below. Now here is r, so this gets cancelled. Like this is r and this is r square, means r multiplied to itself 2 times is r square itself multiplied. Wait a second. Multiplied to itself is number like raised to means how many times it multiplied to itself. So r square means it multiplied to itself 2 times. So now r square here means it's multiplied 2 times r into r. Now this is multiplied by, so let me show you how it works. R by r into r, bro. So here is same r, here is same r. Can't these cancel because opposite? Numerator and denominator are opposite. Like how many I take, how many total was there. So that is totally opposite. Like give and take are opposite, right? Total parts are opposite versus, okay, opposite. Like how many parts are there, how many parts we take. It is totally opposite. So what we do here is these are opposite, r, Like this is r into r, this is r, so extra r is there for this r. So this r can cancel, right? These are opposite stuff, so these can cancel. And anyways, r into 1 is 1 r, right? R into 1 is r. So division is that only. Division is like how many, like 1 is equal to what, r by r. So this is division, like what I would divide to what to get this, like which would have been multiplied. So here, like in what I multiplied to r to get r, 1. So 1 is here, r and r got cancelled, so this is 1 by r. So what happens is here we have cos theta by r, cos theta by r, simple. And I erase this. So now this is a square cos theta by r. Now I multiply r square here, and also I multiply numerator 1 here, but 1 into anything is that only, so it doesn't make sense. So what I said, r square means r into r. Now I multiplied another r from outside. Now this, in like in Minecraft, this r spawned randomly, like a monster, like monster in Minecraft suddenly spawns. Like that here r also spawned randomly. So now it is only itself only getting multiplied, but 3 times. So it just got added 1. And I also said another formula, a raised to m multiplied by a raised to n, if these bases are same and like raised to are different and they are getting multiplied, and since this is like how many times getting multiplied, so we can just add this, bro, like m plus n, a raised to m plus n, and it would give the same stuff, but it is easier to solve. So 2 plus 1 is 3, so this is r cube, r into r into r. So this became a square cos theta by r cube. Okay, so now what happened is, now this is getting spicy, but I don't have space. Let me zoom out, take screenshot or notes, okay, so that I can erase my board. Okay, let me take you from bottom to the top. So this is how it looks, okay. So take screenshot or notes. Now what I would do is I would erase this stuff, okay. Now we found all the stuff we needed. Now we just need to add this. So it's just simple. Cos theta. No, it's not simple, but yeah. Now only thing left is this. Plus cos theta by r plus a square cos theta by r cube, and my marker died again. Yay. This is by the minus cos theta by r minus a square r cube cos theta. Sorry. Sorry for my cough. I'm really sorry, for real. Just my vocal cords are really cooked. So this is this. We found this. We also found this. We also found this. I just arranged and wrote it. Okay. So now what happens here is, okay, but something is kind of missing. So wait a second. What did we miss? Wait a second, bro. Like what? Minus r cos theta. R square cancelled. So this is minus cos theta by r. Done. Minus a square by r cube cos theta. Yeah, that is also correct. Now we had minus 2 e square cos theta by r. Oh, wait a second. By the way, you have to understand this is minus 2a square cos theta by r cube. This is the problem I did. Here it is minus 2a square cos theta by r cube. Okay. Now what I have is cos theta by r. That is also same. And a square by a square cos theta by r cube. That is also same. Right. So I guess this is supposed to be plus or something. I did some sign mistakes here. So this was supposed to be 0 and this is actually 0 because see 2a square cos theta r cube a square cos theta r cube plus a square cos theta r cube 2a square cos theta r cube, like they are same terms, so we can just add it. And so this is 1 here, this is 1 here, so we can add the coefficients, it would become 2. So plus 2 a square cos theta by r cube, like let me show you, 2 oranges plus 1 orange would be 3 orange. So because we just added the coefficient 2 plus 1 whole bracket into orange. So this is how it works, right? 2 orange plus 1 orange would be 2 plus 1 equal to 3 orange. Orange is still there. So this variable is like orange. You can't just change it. Can't change, but some times of it. Some multiple, okay? Some multiple of it. So now a square cos theta by r cube 2 times I took, so it became 2a square cos theta by r cube. Now this is minus 2a square cos theta by r cube plus minus cancelled. Happy life. Now this is minus cos theta by r, this is minus plus cos theta by r, cancel, so it is 0. So this was supposed to be 0. Now we won. Now there are two more steps, but that I would cover in shorts. I'm really sorry. I'm like I want a little water break for now because heat and humidity, summer season. So yeah, I have to take water break right now. So Milne Thompson and the other stuff which was left, analytic, polar form, I would do it, cover it, try to cover it in shorts, or I would come in live. So yeah, thanks for watching. Like, subscribe. See you next time. Bye. Wait a second. I have to zoom out so that you take screenshot and notes. Here you go. I hope it is not much messy, but yeah, it is messy. I'm really sorry, but yeah. So like, subscribe. Bye. See you next time. Bye. Senpai, konnichiwa. Ohayo gozaimasu. Sayonara. Genki desu ka? So bye. See ya next time. Bye. Thank you very much for watching.